let us do this question. In this, he says, uh, there is a block of mass m and another block of mass 2m, which is connected with a spring, and there is another block of mass 2m, and this 2m is going to collide with this, and these both a and b are moving with velocity v naught. That means this string is not compressed; it is present at its natural length. So this is how the scenario will look like. Now let us see what will happen at first collision. So both the blocks are moving like this, and this block 2m block went and hit that C block, which is 2m, and the collision is perfectly inelastic. That means these both will stick together and move further. Okay, so let us write the conservation of momentum here for these two bodies. For B and C, let us write conservation of momentum. So conservation of momentum states that m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. m1 is 2m, that is B block's initial velocity is v naught, plus m2 is that C block, initial velocity of it is 0. Then what happened? It is a perfectly inelastic collision. That means they both are stuck together. They are moving. They'll have their common velocity. So 2m plus 2m into v. So 2m v naught is equals to 4m into v. M and m gets cancelled. 2 ones, 2 twos. So common velocity is equals to v naught by 2. The common velocity with which they are going to move is v naught by 2. So just after collision, block B will be moving with v naught by 2 velocity. The first question's answer would be v naught by 2. Next, he's asking, what is the velocity of center of mass of the system of block A, B, and C? So velocity of center of mass is these three blocks are now moving together. What is the velocity of the center of mass of this block? He's asking, and he's also asking the maximum compression of the spring after collision. Okay. So what happens whenever in the starting, these both will be colliding. Then what will happen? They will have the velocity of 3 v naught by 2. Then what will happen? This block, now B block has decreased its velocity. It from V it went to v naught by 2. That means it has slowed down. So this will be fast. This will be faster enough. What will happen? There will be a compression in the spring, and finally, after some time, everyone will try to move their velocity of center of mass. Okay, after some time, the spring will be compressed, and then what will happen? Everyone will move with common velocity, that is center of mass velocity. So we'll find out what is center of mass velocity. So center of mass velocity is m1 v1 plus m2 v2 plus m3 v3 divided by m1 plus m2 plus m3. Okay, this is the velocity of center of mass. So this is velocity of center of mass is equals to m1 v1 plus m2 v2 plus m3 v3 divided by m1 plus m2 plus m3. So what is m1? That is block mass m, which is moving with v naught velocity. m2 is blocks of mass 2m, and it is moving with v naught by 2 velocity. And m3 is block 2m mass, which is moving with v naught by 2 again, divided by 2m plus 2m, 4m, and 5m. This is 5. Now what will happen? How much you are going to get? Velocity of center of mass would be m v naught plus this and this will go, this and this will go, that is 2m v naught divided by 5m. That would give me 3m v naught divided by 5m. This is the velocity of center of mass. M and m gets cancelled. So velocity of center of mass is V center of mass is 3 v naught upon 5. So let us see if there any option. Yes, that is 3 v naught upon 5. That is the velocity of center of mass. So velocity of center of mass also we have found out. See, what happens is this block, which is attached to the spring, these two blocks, they are going together. These two blocks, first they had the velocity of v naught by 2. Then what will happen? The spring will be compressed. Then all these three blocks will be moving with velocity of 3 v naught by 5. All this will be moving with a velocity of 3 V naught by 5. This one will also be after some time of collision when the spring compresses to its maximum compression. This will move with 3 V naught by 5. This will move with 3 V naught by 5. This will also move with 3 V naught by 5. Okay. I hope you understood this concept. Starting just after collision, these both will have V naught by 2. After collision, when the spring compresses, everyone in that, they are all connected now. So they will all move with the same velocity, that is 3 V naught by 5. I hope you understood this. Now, he's asking the maximum compression in the spring. The maximum compression in the spring can be found out using conservation of energy. We can use conservation of energy and we can find out maximum compression in the spring. Okay. So for maximum compression in the spring, we need to understand what was the velocities previously. This was moving with V naught. These both were moving with V naught by 2. Then final velocity. So initial energies, this body will have half m V naught square. B will have half 2m V naught by 2 whole square. C body will have half 2m into V naught by 2 whole square. This is the total kinetic energy. There is no spring potential energy because the spring is not yet compressed. This must be equal to final kinetic energy. This block has got half m 3 V naught by 5 whole square plus these both will have half, this B block will have half m 2m into 3 V naught by 5 whole square plus half into the C block will have energy of half 2m into 3 V naught by 5 whole square plus, and spring also got compressed this time. That would be, the spring potential energy will also be there. That would be half kx square. Okay. I hope you understood this. This is the initial kinetic energy and this is the final kinetic energy, and we have also some kind of potential energy because the spring is compressed now. So let us check now. Half m v naught square, half m v naught square plus this 2 and this 2 gets cancelled. M v naught square by 4 plus again the same thing, m v naught square by 4. That would be v naught square. This is m v naught square by 4, m v naught square by 4, which is m v naught square by 2. This, if I add to m v naught square by 2, I am going to get m v naught square is the initial kinetic energy. This is equals to, in this, 2 and 2 gets cancelled, 2 and 2 gets cancelled. That is 9 m v naught square by 25 plus 9 m, here we'll have to also 9 m v naught square by 25 plus 9 m v naught square by 25 plus half kx square. This is what we'll be left out with. So that would be m v naught square is equals to, if I take 9, everything 9 m v naught square by 25 common, I'm going to get 1 by 2 plus 1 plus 1 into half kx square. M v naught square, oh sorry, plus is there, so we cannot cancel it out. Here it is plus half kx square plus half kx square. M v naught square will be as it is. Then 9 m v naught square divided by 25 into half plus 1 plus 1, that is 2 plus half is 2 and a half, 2 and a half is 2 into 1 by 2, that is 5 by 2. This is 5 by 2 plus half kx square, 5 ones, 5 fives. This would be 9 m v naught square divided by 10 is equals to half kx square. This is equals to m v naught square. If I send this 9 m v naught square on the other side, that would be m v naught square minus 9 m v naught square divided by 10, which is equals to half kx square. So if I do the LCM and do that, that would be m v naught square divided by 10 is equals to half kx square, 2 ones, 2 fives. So x square is equals to m v naught square divided by 5k. X is equals to under root of m v naught square divided by 5k. This is the maximum compression in the spring. So x is equals to mv naught square divided by 5k. Is there any option? Yes, mv naught square by 5k. So the option for that question is this. I hope you understood this. If you have any doubt, you can comment below. Thank you.